All right, folks, so you had a chance to write your description of this tuff unit. It's called, by the way, the Desert Springs Tuff. And if you want to know about its silica composition, it's what we call rhyodacite. Basically, it's slightly lower silica than rhyolite. Big picture, it's high silica, it's felsic, that's good enough. I believe in my notes, how old is the Desert Springs Tuff? It's like 190,000 years old. Let me double check. I don't remember dates well. 600,000 years old, see? So, 600,000 years ago, there was some pyroclastic flows that came through whatever this landscape looked like 600,000 years ago. Now, what we want to focus on here is that there's actually two distinct flows. It's all part of the same rock unit. We call it the Desert Springs Tuff because it happened at about the same time. But there's actually two distinct flows, and we want to start accumulating the evidence for that. So the first thing is we look at the outcrop as a whole, and Neil, if you just want to do like a general pan of the outcrop, there's that funny boulder on top that looks like it's about to fall on our heads. So that's pretty distinctive. And if we look at the bottom of it, it's quite flat. So that's our first clue. There's this flat-bottomed boulder on top. Eroding something from below is not going to make it flat. The fact that it's flat tells me that, there's something else going on here. Maybe it was originally on top of a flat surface, and we have since eroded away what's underneath it. So let's go investigate the uppermost part of this outcrop a little bit more. One of the things we're going to do is, because we want to compare what the rock looks like at the top to the bottom, Neil's got a chunk of the rock from the bottom with him, and he's going to bring that up so when we look at it up here, we can compare. So we talked about how we're not using rock hammers here because it's a pretty public area. So that means we've got to look a little bit more carefully to find a good fresh face. Like, this is not good rock. It's just covered in lichen. You can't even tell what color it is. So we found a really good one over here. We're going to go to that. You will see that that dark gray black lichen covered rock is not at all what this actually looks like. I think I'm actually going to lift this into the sun so we can get a really good view. There we go. This is what the upper unit looks like. So yeah, Neil, you can do maybe a nice slow pan on it. And folks, you want to start thinking about how this looks different than what we saw down there. Let's see if we can get anything like this going. Yeah, so like right there. I think I've got that mostly lit.
Let's see if we can actually get in there though.
Oh yeah.
Can you, well, I can play around with it.
If you want to see what the
Okay.
GoPro's looking at, if you touch the screen.
Somewhat similar.
Yeah.
I think you might just point it out.
Yep. All right, folks, so let's see. Now that you've had a chance to look at this, first of all, Neil, do you want to hand me that other sample? Perfect. So check this out. Like, this should be really obvious. These are two very different rocks. Now here's the tricky part. It's the same rock. It's tough. It's the Desert Springs Tuff. It happened 600,000 years ago. But these are two distinct flows. So two distinct pyroclastic flows. And the way I would interpret the difference, this uppermost flow, the orange one, has had a lot more chemical weathering, a lot more oxidation, basically chemical reactions. It's fundamentally composed of the same thing. It's a matrix of ash with lots of little rocks embedded within it and pumice. In this rock, the pumice looks black. In this rock, the pumice looks kind of orangish. But there's been lots of chemical reactions here. It turned the ash from the gray color to the beautiful like salmon color. I think it turned the black pumice into this bizarre orange color as well. If you guys want to see that this is pumice again, I can scratch it pretty easily, chew into it with my fingernail. Neil, can you show that little scratch I just did with my fingernail there? Yeah, cool. So fundamentally it's the same rock. It's tough, even though the color is so different. And that's something I want you folks to take away from this, is that color is not a good one when we're talking about tough. What you want to find is that chunks of rocks chaotically embedded throughout it, large pumice that you can scratch with your fingernail, and if you can get a close-up on, it's foamy in texture. And the fact that the matrix is this volcanic ash that's also fairly crumbly if you can get at it. Like right now I'm scraping it with my thumb, and my thumb's got all this fine grained white stuff on it. That's the volcanic ash. Any questions there, Neil? Anything else we should talk about?
This show, it's sometimes when we were walking through here trying to find it, it's hard finding a non-weathered surface, especially when we were up high and not on an outcrop. So it took a little bit of work to find this, and all the other rocks are covered with lichen, and so they all look like the same rock as down below. So it's really important to see that difference.
Awesome. Yeah, it definitely pays to hunt closely for a good fresh face. And that's, folks, a lesson you can take anytime you're out looking for rocks. Try to find the fresh face.